Okay, thank you. All right. It is slightly bizarre to be doing a hybrid workshop, so everyone bear with me for the organization. So I want to thank everyone for not only attending, but also submitting. This is a workshop that has its first edition, and we have had 25 submissions and 60 registered participants. So this is absolutely wonderful. It's a huge amount of stress to start a new workshop. You have catastrophic scenarios where there's only 5 participants in total. It was not the case. We are extremely grateful for to everyone for submitting and participating. Thank you. Um, we have a very packed program with a lot of absolutely fascinating talks, including 2 keynotes. The keynotes are a little spread across the time zones. So one is in a couple minutes and the other one is in the middle of the afternoon local time. And there's a lot of talks throughout the day. So please pay attention if you're a speaker to not overrun as much as you can your allotted slot. I hope that we get to chat on Air Meet or in person. And well, my hope for this workshop is that we can really see the application of programming languages methods to societal problems and specifically the law. There's a rich field that I think is untapped, and I'm hoping that this workshop can provide a space where we can all share our exciting work in this domain area. Some practical details. If you're in the room, you need to ask your question using this microphone so that people remotely can hear you. And you need to hold the microphone right against your mask. Otherwise, the sound is quite muffled, I'm being told. I think that's it for the practical details. I'm available on Air Meet, and so are the student volunteers for any questions, local or remote. And I'm going to hand it off to James virtually, who will kick off this workshop with a new keynote about what he sees as new directions for this field. Thank you.
Hello, and thank you. And it is really nice to be here for certain values of here. I wish that it could be all together more, but fortunately we have at least this platform, and I'm really looking forward to an exciting day of conversations. And to give my thanks to Jonathan and Sarah for organizing this workshop, and the PC and everybody who submitted, and for all of you for being here. It's really thrilling to be part of this creation of a new community. So what I want to talk about is what it means to do law and this is going to be a somewhat law-centric presentation because that's the field that I sit in, and then think about what that means to do law and programming languages. Then the meat of the talk will be about 10 areas where I see exciting research being done and think about some of the directions that could go in. My own journey here is that programming languages were my first love in computer science. And I thought originally that I was going to go and get a PhD in programming languages. And then a bunch of things, including the .com crash, knocked me off of that course and into legal academia instead. But I'm really happy to have come home to PL and really excited by the directions that PL and law can go together. So just to preview, I'm going to put my big ideas in green so you know when I'm talking about things that we haven't done yet, but would be exciting to try. And I'm just putting this slide here to collect them because we'll have a slide for each of them in due course. So to start with, there's a long tradition of interdisciplinary work involving law, but it comes in several different forms, and I think it's helpful to untangle them. So in some ways, the simplest kind of law index is the law of some field, where law directly tells people who do that work what they can and can't do. So doctoring, medicine is a regulated profession, and law pretty heavily limits who can practice medicine and the standards of conduct. Doctors are held to the standards of reasonable members of their field. And hopefully, people who regulate these fields know something about those fields, which involves input and participation from those who are expert in it. The second way that law can relate to a field is it can rely on the knowledge from that field. So there are cases where people have expertise, and that expertise bears on a legal question. So for example, if you're constructing a nuclear power plant, you need to file an environmental impact statement. And one of the things you're going to have to be concerned with is the thermal impact from the discharge from your wastewater going to affect local wildlife populations? Well, you need people with expertise in marine ecology and all the scientific fields that relate to it in order to answer that question. And administrative law is going to have a set of rules for how it incorporates that technical expertise, the same way that evidence law does in civil trials. The most ambitious and in some ways most exciting kind of collaborations are ones where the field is actually a true equal partner with law. And it has its own distinctive methods and ways of generating knowledge. And they provide new insights and new ways of formulating legal questions. So historically, economics had a great boom in the 70s in which it answered questions with different answers than lawyers had provided by looking at contract damages not from the point of view of promise or moral obligations, but in terms of economic efficiency. More recently, linguistics, using vast corpuses and statistical analyses over them, has come in to answer questions about how terms were generally used at particular times in history. And there's at this point an established list of fields where you could say law and history, law and linguistics, law and literature, and people would say, yes, I know people who do that, and these are some of the kinds of things they do. This is a distinctive methodology that a serious law school should have somebody on its faculty who is expert in. So that's the general story. And programming languages in particular, I don't think are ever going to be at the level of one of those broad fields. Instead, it's a kind of subspecialty, a kind of piece of computer science that's particularly important. Within the world of people who do law and tech, which includes computer technology and biotechnology and many others, there's a well-established field within law of people who do law of computers and the internet. Within that field, there's a much smaller group of people who seriously draw on computer science rather than just doing the law of and using it. And within that, there's a very, very tiny group of people, most of whom are in this conference today, who actually use programming languages. I hope that that will grow. And it's helpful to look at other CS subfields to see how they've reacted and drawn upon the uses, the way contributed to law. So one set of examples involves modeling of legal reasoning. And symbolic AI methods have a long history here, which will come back a bit later in the course. More recently, a lot of machine learning methods have realized that law generates remarkable corpuses of information from which structure and other insights can be extracted. Other legal areas are so connected to a substantive CS field, they really have to draw on it. So you can't do privacy law without engaging with computer security. You can't seriously do modern telecom without knowing a fair amount about networking and thinking about future networks, and so on. So to come to programming languages in particular, I want to start with one of my favorite Frederick Book quotes: "The programmer, like the poet, works only slightly removed from pure thought stuff." That programmers create things, important, meaningful things to people, out of pure abstraction from their imagination. And with only a slight abuse of the language, you could say the same thing about lawyers. So there's an analogy here between the texts that programmers write and the texts that lawyers write. These are both linguistic professions that make things with words. We use language to create abstractions, to reason about them, to interpret how they actually work. Programmer who uses the right words in the right way makes computers run the internet, fly airplanes, deliver packages, all kinds of stuff. A lawyer who uses the right words in the right ways creates companies or distributes property or establishes new laws. They change people's rights and obligations. And that, I think, is the key to places in which programming languages in particular have a distinctive advantage within CS. There are other CS fields that do very interesting things with law too. So AI can deal with legal structures and reasoning about them, and natural language processing is increasingly getting into analyzing legal language. But there's a sense in which programming languages provide a very principled framework to look at legal structures in something like the same way that lawyers do, using the linguistic expressions used to create them. That is, understanding the recurring deep patterns in how this set of words makes this thing happen. So, to put it in more familiar terms, there's a certain expressive power to the right PL abstractions in capturing the structures and abstractions of law. So many of the examples I'm going to try to work through involve trying to harness that expressive power to look at law in new ways. So now let me run through what I see as 10 interesting research tracks and the directions that they could head in the future. This is a little bit subjective. It comes from my perspective, sitting more on the law side. Some of these are very far advanced. I'm simply talking about things people are already doing. In some cases, it's a bit more speculative. But here are sort of a slice of what all the things I find really exciting and interesting about this field. So starting from the sort of narrow nitty-gritty details, and this one's in some ways draw least on really powerful PL methods, let's go back to the law of programming. And programming isn't a regulated profession. There are people who think that it should be more of one, but for the most part, you don't need any particular legal qualifications to write code. But once you do, law kicks in lots of ways. That there are lots of ways to violate the law using software. If you want, I can teach an entire course about internet law that covers a lot of those. And sometimes those laws turn not just on what a program does, but also on sometimes on what it means, or how software is written and how programmers write it. And when that's the case, programming language experts have relevant expertise. So to give one classic example, the argument against software patents is sometimes presented on the lines that software is just math, and therefore you can't own math because it's an abstract idea. And that idea, right or wrong, draws upon a view of what a program is that comes straight out of programming language theory. It's a view about the mathematical abstractions of programs, that a program is what it denotes in some mathematical domain. Is that a correct view? What are its implications? How does it work? This is an area on which programming language experts can say something useful. You could do the same for copyright or the First Amendment, all of which try to look inside programmers' code to separate some parts that are more expressive or original from the parts that are merely functional and don't involve the exercise of the human imagination. A second track that's pretty fruitful and is everywhere these days involves domain-specific languages for contracts in particular. And so something that people who talk about CS and law in programming languages frequently refer back to is the 2000 Composing Contracts paper that presents this set of functional combinators for financial option contracts with a very elegant semantics and a really nicely chosen core set. And there have been a lot of projects, more in fact that I could name on one slide when I started trying to make a list, that try to model the distinctive structure of contracts. They involve obligations, that's the ontic. They involve two or more parties. Contracts change state based upon events. These are interesting technically. And there's a fair amount of academic work on logics to try to model that structure. The rise of blockchains means you have smart contract languages that are trying to replace legal contracts with ones that run on a blockchain. And then there are a bunch of hybrid projects trying to combine the human readable legal code with the machine readable executable code in a single contract. So just to repeat sort of the obvious, there's a very exciting opportunity here to try to really fill out the space of hybrid contracts that are partly focused on humans and partly focused on computers. Can we write contractual terms once and then compile them to something that either humans will execute in court or computers will execute automatically. If we can do this, it might lead to better ability to prevent or detect bugs in the logic of the contract, preventing and spotting cases where it goes into a failed state or becomes indeterminate. Can we execute automatically the parts of a contract that don't require careful human oversight? And possibly could we get out of this a clearer story about which parts of this are meant to have legal effect and which ones don't, and how the automation and the legal enforcement relate to each other. More generally, I think we're seeing a really interesting surge in legal domain-specific languages. I've been working on Orlando with Basu and Anshuman and Nate Foster, and we'll be seeing a little bit more about this later today, but the idea is we're trying to translate from a natural-like language to a more abstract representation to represent interest in property. And then, of course, there's CADA, which models legislative defaults and has this nice declarative programming language with exceptions that compiles to a lambda calculus variant, and it's being used to verify a new implementation of the French tax code. So this is just an open field. Where else can we create legal DSLs? I think the features that make a field attractive for this are that it uses rules, so you can have definite yes/no answers. There's enough of a recurring structure that it's worth doing a programming language and not just some kind of one-off expert system. And their participants really care enough about clarity that they are likely or would willing to accept the outputs of these programs as correct or authoritative, rather than just someone's guess that they can dispute. So when I think about areas of law that are amenable to this, at least the lowest hanging fruit are areas that are transactional, where you're trying to put together a set of legal instruments to do a thing and to cause the ownership or obligations to shift in some specific way that the parties who have the power to do it agree to. And I think a lot of property law has this character already because years and centuries of judicial decisions have given it a fairly stable core. So doing title assurance, for example, and reasoning about transactions in the past may also be the kind of thing where, yes, the courts and lawyers are already in some sense executing algorithms that could be formalized. The history of legal logic programming, I think, comes into this in an interesting way. So you've got this very long history of using symbolic AI to model legal reasoning. Thornton McCarty is going to present on applications of this later today. He's been at this for over 4 decades. And one of the recurring challenges I think I see in the literature there is that legal reasoning has some really distinctive characteristics. There are things about it that are not natively governed by some logic programming languages. There are interesting uses of counterfactuals, non-monotonic inference, how do you represent obligations? And so there's been a proliferation of extensions of programming languages that have appropriate language features for specific legal problem domains. And this ties into paper that Basu is going to present later today on legal calculi. You notice that there's a bunch of common projects start from a more traditional PL-like front end and then generate something that looks more like a calculus, like a combinatorial logic or lambda calculus as an intermediate form. So there seems to be something very fruitful about having a very clean core with only a small set of primitives adapted to legal specific functions. So that leads me to wonder, what are the orthogonal primitives of law? Examples in the literature include trying to do sequencing and ands and ors of legal obligations. There's a clear, well-recognized line of research on defaults and exceptions and modeling that default feature. And there's a lot of work on trying to model this Hofeldian in legal theory structure of rights and duties, that if I am obligated to do something for you, you have a right to expect it from me, and that people have powers to shift rights and duties. Those structures seem to have an underlying elegance. So the general trend is what things here can be given clean minimal formulations, how can they be combined, and would it help to have back-end support? That is to say, here is a virtual machine model that has some built-in exception handling default system that is just so common in legal reasoning. This is a common useful backend for multiple legal front ends to target. So getting a little more abstract, I want to talk a bit about language features and common solutions. So as a starting point, Sarah Lawsky, in a paper on statutory drafting, notes that the scope of definitions is often ambiguous, that a term, it's not clear which portions of the code it ought to cover. And this is not a thing that should be ambiguous. Some legal choices are deliberately open because they depend on facts. But does this term apply to this subsection is not a question that should have an indeterminate answer. So her proposal is to have logical forms for these statutes that make the scoping explicit. So to rephrase that, the idea is use a programming language whose features prevent a certain kind of bug. And you could generally ask what kinds of language features would help for legal drafting. If legal drafters had available a framework that let them or forced them to formalize certain, not all, but certain features of their work, would this help prevent common difficulties or mistakes in statutes? That is, would it help to have some clear notion of variable binding when writing a statute to explain what this idea captures? And you say later, said some. Would we help to have a better, more canonical way of doing cross-referencing? Should we have procedures for reflection and counterfactuals that let them clearly say, if the total would exceed $100,000, except for the application of subsection B2, then, and so on. What other language features that programmers and PL designers use regularly would help in statute drafting? More abstractly, something really interesting in the legal space is this interest in design patterns. So in software design, a design pattern is a general repeatable template of solutions to a commonly occurring class of problems. So constructor or abstract factory that generates instances of a class. The roots here come out of Christopher Alexander's work in physical architectural theory, looking at the language of patterns used to create spaces that people live and work in. But it's been adapted to software design and user interfaces, and there's an underlying strong undercurrent of programming language theory in that. It's very closely related to theorizing about what objects are and what an object-oriented language feature should have. There's a nascent literature on legal design patterns. It's not big, but it's there. People are working on it in the space of contracts especially, and it has its own very interesting depths to architectural theory that I don't have the time to get in here, but are fascinating. So there are two directions you could go here. One of them would be to take existing literature on design patterns in software and user interfaces and just say, are some of these already recognizable in legal systems? Can we find proxies and singletons in law? And what does that tell us if we can? The other, more ambitious approach would be, can we craft pattern languages for specific legal areas? Can we actually use this idea to recognize and understand the patterns used by contract drafters or used in copyright? What are the pieces these bodies of law are made up of? Even more broadly, there are the design principles that PL designers try to encourage when they create good PLs. So take modularity and systems for decomposing large programs into modules. Modules are interacting subsystems that are tightly coupled internally, but weakly coupled to each other across an abstraction boundary. This comes from Herb Simon and the cybernetics literature, and it's, I think, safe to say it's a pretty central principle of computer system design. Good programming languages encourage and support it by making modules a language feature. Well, so there is a literature in legal theory about modularity. Drawing on Simon, Henry Smith has written a lot about how property is structured in a way that's actually pretty highly modular and economizes that information cost for participants. Others have started to apply the same ideas to contracts, to legislative drafting, and you could keep on looking for ways in which the law is modular, but I think a more exciting way would be to ask what other big PL design ideas show up in law? Can we find places where compositionality is a recurring feature of how legal regime works? Could we find recursion or type safety somewhere in law? And I have my ideas. I think parts of evidence law have been written deliberately to be extensible, for example. But I think there's a lot of untapped work here in which things that every PL theorist and lots of programmers know on a deep level could be pretty useful if they were known by lawyers and legal theorists as well. So descending from the very abstract to the very concrete, as somebody who has worked with both programs and law, I have to say it's a much more painful experience to work in the legal space. That is, the quality of the tool chains and IDEs on the programming side is incredible. Yes, there's often a lot of fiddling with configurations and installation, but once you have the system up and running, the support that it gives you as you are working is just incredible. Over on the legal side, I am passing back and forth Microsoft Word documents with track changes on all the time. And we're lucky because we have like XML and some structured tools on the legal side that are making some inroads. But there are also pockets of holdouts who are still using WordPerfect. Now, right now, this is a moment of really exciting ferment in the legal tech space. And some of that is just pretty crude Outlook plugins, but some of it is based upon pretty serious programming language work. So I'm not doing much more than saying, this is what people are working on, but it's exciting, is to say, what else can we do in the development environments that lawyers use? What else, as they're working on drafting legal documents, could we help them with by being more aware of the language that they're using and treating it more like a programming language? Syntax highlighting and auto formatting are the tip of the iceberg, but also see this bringing modern version control, modern testing, the ideas of interactive debugging or static analysis. There's lots of places in which there's so much low-hanging fruit for the way that lawyers do their work with just off-the-shelf PL ideas. Also useful on the tool side are things that help people learn how legal concepts work and construct them by interactively modeling legal documents. So there are a couple of things from the PL world that help you. One is visualization, and in our own work on Littleton for interpreting Orlando and property law, we took an off-the-shelf diagram for drawing railroad diagrams for JSON syntax and used that to visualize the interest. It worked perfectly. Sarah Losky's practice problems in tax law harness the advantage of interactivity. There are actually a bunch of nicely interactive law apps that use something PL-ish under the hood. And there are a bunch of exciting projects that are basically trying to do literate programming for law and interweaving comment and executable text. So the vision, I think, here is like a Jupyter notebook for law. We can visualize legal structures using PL abstractions, have a very tight feedback loop where you make a change and you immediately see what it does differently, and you interweave the human and computer-facing parts of these legal texts. Do all three of those at once, And I think it's something people are pretty excited to use. And finally, drawing out to the really big questions. I think that these are both linguistic professions, that lawyers and PL scholars are really both working with words. So in a sense, what they're both doing is interpretation, trying to understand what a text means. Now, to a lawyer, an interpreter is something dramatically different than it is to a PL theorist. The lawyer means a person who's poring over the document. The PL theorist means a particular program that interprets programs from another language. Maybe they can learn from each other. I think this is of intellectual interest to people who want to understand what both fields are all about. I think it's also of practical interest because it's necessary to understand what people on both sides of this field are doing when they interpret texts in order to make systems that people who do law feel meet their needs in a new way. So I would ask philosophically questions like, how is it different when a person interprets text versus how a computer does? Is it something inherent, or is it a matter of techniques that in theory either could do both? Does the fact that we have computers now, which are capable of doing different kinds of program interpretation or statistical analysis, does that change how legal text should be written and interpreted? Could we think about programming language theory differently using some of the concepts from legal interpretation? I'm really excited about this stuff. I'm trying to write a book on it. That book was due a year ago. The pandemic has not been kind to my progress, but I think these are really interesting questions. I would love to see people working on them. So to finish, I think the caution I would give is that this stuff is hard. It's harder than I thought it would be when I started trying to do it. Different fields are truly different. Everything from where do you publish, to how do you write, to what constitutes a sufficiently rigorous argument. There are things in law that are super annoying that are just considered part of how you create a rigorous paper. The footnoting has to be done a certain way. On the other hand, you can hand wave things that a PL theorist would not let you get away with, and my colleagues have not let me get away with. Another problem is that legal scholars think they know everything because their field connects to everything. There's an insult among historians that lawyers do law office history when they want to figure out what a term meant at some point in history. They basically read a couple of books and declare they understand it, which is dramatically different from how historians actually work. On the other hand, some other fields have been pretty imperialistic when they come into law. The economists really start up a lot of resentment, claiming they knew better than everybody in the field. In this, working with trained collaborators who understand the other field, so people working from both the PL and law side, has been incredibly fruitful. And people who have dual training, who have really gone deep on both sides to translate. So I think in the future, looking for those collaborations and ways to give people training on both sides will be important to building a lasting field. But then the positive part, which is I really, really like the way that programming language makes ad hoc systems into principled ones. That programming languages as a field is a way of bringing order to the chaos of coding by providing good, clean abstractions that are actually usable in building systems. And using those abstractions to do sophisticated reasoning, to make the systems better, to prove them correct, to find bugs, to do all kinds of things that make programming less messy. Law and legal tech could use more of that. I think the Catalan French tax code project is a really exciting example of this, taking this ad hoc off-the-shelf system in a custom language and making it in a modern language that supports much better verification. And the other, just from a purely lawyer's point of view, the work involved in taking a body of law and subjecting it to a programming language approach has forced me to understand that body of law in a much deeper way. And I think you see similar intellectual benefits everywhere that lawyers take on the real work of formalizing what it is that they do using PL insights. Whether it succeeds or fails in representing concepts, it produces a new and I think much richer way of understanding. It's a Knuth quote that I love, that science is what we understand well enough to explain a computer. he says that art is everything else we do. But there's a real, people talk about legal science sometimes dismissively, but there's a real value in trying to understand it well enough to explain it not just to other lawyers, but also to computers. So with that, I am done, and I look forward to conversation.
You opened up the workshop. That reminded me, I thought you tied together many ideas, and I found it really amusing that you cited that paper about contracts from 2000, because I actually worked at a company for an internship that does this, Lexify, like about 10 years ago. So it was very funny to see you tie together papers and things that go like so 2 decades back all the way to here and like put them together comprehensively. The way we're going to proceed now is if anyone in the room wants to ask a question, they should come up here and ask the question into the microphone. And meanwhile, we're going to put up some questions from AirMeet on the screen. So let's start with the most upvoted question from Giovanni. James, if you want to like add to that.
That's a really great issue. I think both, or rather, I would look for places in which human language is unnecessarily ambiguous. And legislative drafting manuals have a bunch of advice that is targeted towards do X rather than Y because Y is ambiguous in a way you don't intend. And I think we can there's a lot more that can be done there, but there's a limit to how far you can push drafters, at least as long as the world remains as complex as it is, which is basically forever. So I think you can get some progress on the first, and then whatever you can do later is helpful. One of the things that's really difficult about legal interpretation is that it's not purely linguistic, that the preferred grammatical interpretation of a statute, for example, will be influenced by views about what the drafters were trying to do. And to do that resolution requires a lot of world knowledge that's going to be very hard to do linguistically.
Okay, thank you. Next question from Meng.
Yes, and I don't know. That I think specification languages are in the picture, but I don't know how difference in how they map onto law. And I would love to see somebody clarify that or say that it's fatally ambiguous in the legal space. I don't know.
No one in the room. Should I continue with the AirMeet questions? Okay. Okay, here's a classic one. How does or should the field relate to AI and law? If you can.
Yeah, so I think that AI and law comes in a lot when it comes to reasoning about legal concepts. And this is something we've had to engage with in the Orlando Littleton work, because it turns out that if you want to have property change hands on something like if A is married, then there's actually a lot of legal reasoning that can go into determining whether person A could ever in the future marry. It depends on who is married to who else in the law of marriage. And it turns out that that's an AI problem working under what looks like a simple PL specification. So to some sense, every sufficiently interesting legal project will at some point kick off into AI because you have to have some reasoning about what has happened or what is possible and what could happen under certain circumstances. At the same time, I think that PL in particular has a virtue of looking at the legal language that AI reasoning sometimes doesn't. That when you have the structured form of a PL grammar or PL semantics, it provides a framework for generating the propositions or structures that AI reasons over, or AI can help you take complex natural language and map it onto the cleaner core of a PL style grammar. And yeah, the fields are very overlapping at their boundary.
Okay. The next most upvoted question, please.
I don't know how much it's possible to embed PL in laws yet. There are certainly regulations and statutes in some places that have equations in them. So if you look through the Federal Communications Commission's regulations, when they're regulating the power at which transmissions can take place, there's embedded math in there all the time. So some of that certainly could be formalized using programming language concepts. And I think I'm a fan of trying to make statutory drafting more PL-like as a way of removing some of the unforced errors in it. This is a long-term project, and previous attempts to codify and take existing bodies of law and restate them in clearer, simpler language have not gone terribly well, simply because the backwards compatibility problem is so huge. So I'm a fan of incremental progress here. I think it's going to be incredibly hard, bordering on impossible, to uproot and replace the whole system.
Okay, we have one upvoted question from Jason Morris.
So I think that judge-made law is especially hard to get at using programming languages, because the essence of a judicial decision is it's an explanation and justification of the reasoning for a result. And given that most of what they produce is intended to describe and justify rather than to actually constitute the law, judicial decisions tend to be unstructured and just more variable. Statutes, at least, because the drafting is concentrated in a group of people who have clear directions and some incentives to be very precise and more broadly applicable, it's a more fruitful domain. There's more structure there to hook into. So I see PL as coming later, if at all, for judicial decisions.
Okay, well, I guess that concludes our Q&A session. Let's thank the speaker again, both in person and virtually.